All right, let's talk about something that's kind of like the hidden blueprint of our digital world, network topologies. It's all about the fundamental choice of how we physically connect computers, and believe me, this one decision has massive consequences for speed, reliability, and yeah, even cost. So, let's dive in.
So, have you ever really stopped to think about it? I mean, beyond just plugging in a cable or connecting to Wi-Fi, what's the actual layout? When you've got dozens or maybe even thousands of devices, how do you organize them so they can all talk to each other without it just becoming total chaos?
Well, it really all comes down to the shape. The official term is topology, which is just a fancy word for the physical layout of the network. The best way to wrap your head around it is to think of it like a roadmap for your data. You know? Is it a single main street, a big central roundabout, a circular highway, or a crazy complex grid? Each one has a totally different traffic flow and its own special kind of traffic jam.
Okay, so let's start with the most basic roadmap there is, the bus. This is pretty much the most straightforward way you can get a few devices hooked up and talking to each other.
And it is, well, it's exactly what it sounds like. You've got this one main cable, that's the bus, and every single device, whether it's a computer, a printer, whatever, just taps right into it. So when one computer wants to send something, it basically just shouts the data down this one shared hallway, and all the other devices are listening in, waiting to hear their name called.
But, like everything in tech, there's a trade-off, right? The good news, it's super cheap and really easy to set up. You don't need a lot of cable, so it's perfect for a small, simple network. The bad news, though, is pretty big. Since everyone is sharing that one line, things slow to a crawl the more devices you add. And trying to troubleshoot a problem? Oh man, it can be a total nightmare.
And here's the real kicker, the Achilles heel of the bus. If that one main cable breaks, anywhere, just one little break, the whole thing is done. The entire network just comes to a screeching halt. It's a huge, massive, single point of failure. So that obvious fragility brings us to the next idea. What if instead of sharing one big cable, every single device got its own private line to some central point? Well, that's the whole idea behind the star topology. So in a star network, every computer gets its own dedicated cable, and they all run back to a central box, like a hub or a switch. All the traffic has to go through that central point. It's kind of like a post office for your data. Messages come in, the hub sorts them, and sends them out to the right address.
Now, this setup immediately solves that massive problem the bus had. The huge plus here is reliability. If one computer's cable fails, it only takes that one computer offline. Everyone else is fine. But you can see the downside, right? You need way more cable, and now you have to buy the central hub, which adds to the cost. And here's the irony. In solving one single point of failure, we've just created a new one. We protected against individual cable breaks, but now we've got this new, even bigger Achilles heel. If that central hub dies, every single device goes down. The entire network is completely dead in the water.
Okay, so a single line is risky. A single central point is also risky. What's another way to tackle this? Well, what if we just got rid of the center completely and made a circle? And that brings us to the ring topology.
With a ring, each computer is connected to exactly two others, its neighbors on the left and right, and that forms a perfect closed loop. Data travels in just one direction, around this circle, getting passed from one computer to the next, kind of like a baton in a relay race, until it gets where it's going.
The upside to this is pretty cool, actually. Because everything flows in such an orderly way, the performance is really stable and predictable, even when the network is busy. But the flip side is that this very orderly system is also, you guessed it, fragile. If just one device or one cable fails, the whole ring is broken. Heck, even just trying to add a new computer can shut the whole thing down for a bit.
Yeah, you can probably see the problem coming a mile away, can't you? That neat, orderly flow is also its biggest weakness. If just one computer in that ring goes offline, or one little cable gets unplugged, the relay race just stops. The baton drops, the loop is broken, and the whole network is down.
So we've looked at 3 designs now, and they all seem to have these critical single points of failure. So what if we just went to the absolute extreme? What if we decided to build a network with no single point of failure? Well, that's the dream, and that's the promise of the mesh topology.
In a true full mesh network, we're talking about total, absolute connectivity. Every single computer is connected directly to every other computer. So if you have, say, 5 computers, each one has 4 cables running out of it, one to each of the others.
It creates this incredible web of connections with tons of different paths for data to take.
And this right here is the ultimate trade-off. On one hand, the reliability is just unbelievable. If one cable gets cut, or even a few of them, who cares? The data just finds another way to get there. It is literally built to survive failure. But the catch is a big one. It is wildly, ridiculously expensive and complicated. The number of cables you need just skyrockets every time you add a new device. It's just not practical for most situations.
Okay, so we've got 4 completely different designs, 4 different philosophies, really. The straight line, the central star, the closed loop, and the connect everything to everything web. Let's put them all side by side and really see how they stack up.
When you lay it all out like this, a pattern becomes super clear. It's really a spectrum. On one end, you've got the bus. Super simple, super cheap, but also super fragile. Then on the complete opposite end, you have the mesh. Unbelievably reliable, but insanely complex and expensive. And the star and the ring, they're kind of in the middle, each trying to find a different compromise between those two extremes.
So what's the big takeaway here? It's that there is no best option. Not one. The choice is always a trade-off. What are you trying to optimize for? Is it cost? Is it reliability? Is it simplicity? Or is it pure performance? The right answer completely depends on what you actually need the network to do. And that leaves us with one last question to chew on. The internet, right? It's the biggest network in the world, connecting billions of devices. It has to be incredibly fault-tolerant, and it's just massive. So based on what we've just talked about, what kind of topology, or more likely, what crazy combination of all of these do you think makes the whole thing work? It's something to think about.